Hello friends, welcome back to Cloud Pedagogy. In the last session, we could able to fit a database which is DynamoDB for our student directory application. In this session, let's talk some more about Amazon DynamoDB, like what it is exactly and what are the core components of Amazon DynamoDB and how to secure it. So, what is Amazon DynamoDB? At the most basic level, DynamoDB is nothing but a simple database. It is a serverless database, meaning that you don't need to manage the underlying instances or infrastructure powering it. Amazon DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. DynamoDB lets you offload the administrative burdens of operating and scaling a distributed database so that you don't need to have to worry about hardware provisioning, setup and configuration, replication, software patching, or cluster scaling. So with the DynamoDB, you can create database tables that can store and retrieve any amount of data and serve any level of request traffic. You can scale up or scale down your table's throughput capacity without downtime or performance degradation. You can use the AWS Management Console to monitor resource utilization and performance metrics. DynamoDB automatically spreads the data and traffic for your tables over a sufficient number of servers to handle your throughput and storage requirements while maintaining consistent and fast performances. All of this data is stored on SSDs, which are solid-state disks, and is automatically replicated across multiple availability zones in AWS region. That is useful to provide built-in high availability and also data durability. So, what are the components of Amazon DynamoDB? In DynamoDB, tables, items, and attributes are the core components that you work with. A table is nothing but a collection of items, and each item is a collection of attributes. DynamoDB uses primary keys to uniquely identify each item in a table and secondary indexes to provide more querying flexibility. Let's look at the tables. They are just like similar to other database systems. DynamoDB stores data also in the tables. A table is nothing but a collection of data. With DynamoDB, you don't need to create a database with tables that relate to each other like a relational database. Instead, you create standalone tables. A DynamoDB table is just a place where you can store and query your data. Here, you see the example table called student that you could use to store information about first name, last name, location, and job title, etc. So, next component is item. Each table contains 0 or more items. An item is a group of attributes that is uniquely identifiable among all of other items. In a student table, each item represents a student. Items in DynamoDB are similar in many ways to rows, records, or tuples in other database systems. In DynamoDB, there is no limit to the number of items you can store in a table. The third component is attributes. Each item is composed of one or more attributes. An attribute is a fundamental data element, something that doesn't need to be broken down any further. For example, an item in a student table contains attribute called student ID, first name, last name, and so on. Attributes in DynamoDB are similar in many ways to fields or columns in the other database systems. That's about the core components of the DynamoDB. Next, we'll see security with Amazon DynamoDB. DynamoDB also offers encryption at rest, which eliminates the operational burden and complexity involved in protecting sensitive data. DynamoDB stores data redundantly across ACs and mirrors the data across multiple drives for you under the hood. This lessens the burden of operating a highly available database. DynamoDB, beyond being massively scalable, it is also highly performant. DynamoDB has a millisecond response time, and when you have applications with potentially millions of users, having scalability and reliable lightning fast response times is important. To summarize, DynamoDB is not a normal database in the sense that DynamoDB doesn't require a rigid schema or manage complex relationships or constraints. Of course, relational databases work great for a lot of use cases and have been the standard type of database historically. However, these types of rigid SQL databases can have performance and scaling issues when under stress. The rigid schema also makes it so that you cannot have any variation in the types of data that you store in a single table, so it might not be the best fit for a data set that is a little bit less rigid and is being accessed at a very high rate. This is where non-relational databases like DynamoDB come in handy. So that's all for today's session. I hope this is useful and helpful for you. See you in my next video. Until then, take care.